Here is another problem from homework number 11. And I didn't write the whole question at the top because it repeats itself in each part. So let's just start here. In a lottery game, the jackpot is won by selecting 6 different numbers from 1 through 45. So we just get those numbers to choose from, not all the way up through 99 or whatever. And the question is, what is the probability of winning the jackpot in this game? And we're also told that order does not matter. All right, order does not matter. That's important in a minute. But because this is a probability question, I'll throw this at the top. We know the probability of an event is the number of successes over the total possible outcomes. Okay, and in this case, we want to find the probability of winning. Again, in a problem like this, the numerator is pretty easy to find. There is only one winning lottery ticket. All right, there's only one way to win. All right, so the challenge comes not with the numerator, but with the denominator. How do we find the total number of possible lottery choices, lottery picks? All right, we are told because order does not matter, and we are also told that we are choosing 6 numbers out of a set of 45, we can conclude that we have we have a combinations problem here, where n is our 45 and r is our 6. This is the total number we're choosing from, and this is the number that we're choosing out of that 45. All right, so I'm just going to write that right here. n 45 choose 6 equals 1 out of. And you can do that right on your calculator. And hopefully you will get 8145060. 1 out of 8,145,060. That's your chance of winning. All right, let's move on to the next question. In a pick 4 game, you win a straight by selecting 4 digits with repetition allowed. Okay, that's important. With repetition allowed. And we want to get the same 4 digits. What's the probability of winning this game? And we are choosing between the numbers 0 and 9. So when repetition is allowed, we're not using combinations or permutations because factorial is not involved. Factorials are involved when you're not when you can't repeat, because then each time it goes down by 1. Once you've chosen a number, you don't have that number to choose from anymore. So you don't have as many choices, and it goes down by 1, and that's hence the factorial. But here, because we're choosing 4 digits, 1, 2, 3, 4, and I could choose 5, 5, 5, 5. I can repeat digits. So every single time I have the choices between 0 and 9. I could choose any one of those 10 digits. So I have 10 choices for this first number. The thing is, I have 10 choices for the second number too, because I can repeat it. So it doesn't lessen as time goes on. So in this case, it's an exponent question. 4 digits, and we have 10 numbers to choose from. So it just becomes 10 to the 4th power. Or over here, we could think of it as n to the power of r. That's the formula we use in this case when you where n is the number you have to choose from and r is the number of things you have to choose. And that's going to, if you just do that right on your calculator, you're going to type in 10, use your caret button, and the number 4, and you're going to get 1, 2, 3, 4. You are going to get 10,000. So this is a probability question, so I made the mistake of not writing that first. But in this particular game, probability of a win, and again, this is the same formula as up here. There's only one winning number out of a set of 10,000 possible choices. Okay. Okay, finally, let's take a look at this last part of the question. The Pick 4 game returns $5,000 for a winning dollar ticket. What should the return be if the lottery ticket organization were to run its game for no profit? So, in other words, it's paying fair odds is basically what we're looking at here. Kind of run out of space, but in essence, we know that the probability of winning, which is 1 over 10,000, times the return, which is what they pay you if you win, should equal 1. That would be a fair payout. So what would the return have to be? The return would have to be, can divide 1 by 1 over 10,000, do the algebra there, but you'll discover that the return should equal $10,000. That's what they should pay you if it were fair odds. However, they only pay $5,000, and that's how quite often, that's how lotteries make so much money for the stage or for whatever it is that they're running a lottery for, because they never pay out the one-to-one return. The risk you take is much greater than the payoff you'll ever get. Okay, so go ahead and try a problem like that. Good luck.